63, gentlemen, 0.55. What are the units? What are the units on mass? AMU, atomic mass units, if, gentlemen, if it's an atom. So if we've got 10 atoms, what's the total mass? 635.5. So your periodic table gives you a mass for an atom in atomic mass units. And you can write it like that. What's the short form for AMU? U. So, 10 atoms times 63.55 atomic mass units per one atom is 635.5 U. Is that a very large mass or a very small mass? It's going to be very small because we're talking about 10 atoms. Now, the likelihood that you will ever have to be in a position where you have to separate 10 atoms of something, pretty slim. But on paper, you have to know what these mean. Ronak?
Couldn't 63.55 be grams per mole?
It can be grams per mole. Do we have a mole of atoms? No. We've only got 10, which leads into B. Okay? This is how to find the atomic mass in use when you have a certain number of atoms. You take the number of atoms, multiply it by the number, put your units, atomic mass units. Right? So, when it wants it in grams, we know each mole of atoms has a mass of 63.55 grams. Do we have a mole of atoms or do we have more or less than a mole? Cole says low, way low. Way less. So you have to figure out how many moles you actually have. How do you go from the number of atoms, Isaiah, to moles? Cool? By? No.
Divide by
We got Avogadro's number over there. N is 10. Na, 6.02 times 10 to the 23 atoms per 1 mole. So moles is going to be number of atoms divided by Avogadro's number. Are you going to have a big number or a small number? Yeah, it's going to be pretty small. All right, so take your calculator. Ten divided by Avogadro's number. Bless you. It's only 10 atoms. When you go to, you know that there's 1 carbon in 1 molecule of CO2. We've got the same number, and what number would you get then for oxygen?
That times 2.
That times 2. Yeah. Okay? Ali wants to make 600 cookies. I didn't say he wanted to eat them. I said he wanted to make them. Okay, I want to know how many pounds, LBS, how many pounds of butter we're going to need to buy. Oh, 1 cup of butter makes 50 cookies.
Isn't that kind of easy?
There are 2 cups in a pound. Think you know the answer? So, 1 cup of butter makes 50 cookies. Or 50 cookies per cup of butter, right? There's 2 cups in every pound. And we need to make 600 cookies. This is all the information you need. Take the unit that you're looking for. It's in the first ratio that you use, and it has to be on top. So we're going to use 1 pound contains 2 cups of butter. We cannot use that ratio again. But you've got to get rid of cups. Is there another value up here that has cups in it?
Yeah.
Right? Now, cup is on the bottom, so you need cup to be on the top of the next ratio so that they cancel. So 1 cup, 50 cookies. That ratio's been used. My cups have canceled, not the numbers, just the units, but now I've got cookies in there as well. I need cookies to disappear, so the next value that I have has to have cookies on top. 600 cookies. You can do this math without a formula. So now all you do is you take every number on top and multiply, and you divide that number by every number that's on the bottom. Your units are going to be pounds because they're the only one left. So we've got 1 times 1 times 600 divided by 2 times 50. 6 pounds. You didn't need a formula. All you needed to do was use your numbers with their units, and that's it. This is called dimensional analysis. It will be your best friend if you take physics and chemistry, because you will not need to use a formula ever again.
Ever.
Ever.
Never
Okay.
again in physics.
Okay, never. Okay, I'm crossing my fingers. Maybe not never. In a day.
24.
We're getting there.
Wait, did we just do this in physics?
Okay, so now we've got days.
Yep.
We need another ratio.
Years to days.
Years to days.
1 year is 365 days.
1 year is 365 days. All right. Which one of those ratios contains your unit that you want? Nico,
The last one.
the very last one. Is year on top?
Yeah.
So start with that one. What is on the bottom of that ratio determines what's going to be in the top of the next one.
3600. Why should you use 60%?
So Christina, what's on the bottom of that ratio? Days. So which one of these ratio has days in it? Can we use that the way it's written in our next ratio?
No.
Why?
Yeah, no kidding, yes.
You're going to write exactly that?
Yeah, because days are on the bottom there, so days are on the bottom there.
No, you want days on the top.
Kidding, that's for sure.
Okay. You want the days on top so the day cancels.
Okay.
The word day will cancel. So one day, 24 hours. What's going to come next?
The second one, but you have to flip it.
You have to flip it. I like to cross them out as I go so I don't accidentally reuse them. What's going to come next? Flatty.
The first one?
The first one, is it going to stay like that or am I going to flip it?
I'm gonna flip it.
We're going to flip it. All right, now that we've got that, is there a ratio that's got seconds in it?
Yeah.
There is. There is. 1,000 pennies per second.
Gotta switch that.
Switch that. So far, days have canceled, hours have canceled, minutes have canceled, seconds have canceled. Oh, I'm left with pennies. How am I going to get rid of pennies? Yep.
To be times a mole of pennies.
Times the mole of pennies.
What?
A mold of pennies.
Oh, no way we're doing that.
Times a mole of pennies.
Since when is mold and pennies? I thought mold was in like elements.
Moles
I'm
is
so
just
confused.
of,
Moles just, yeah, it's just a number.
Why are we just getting introduced to moles? Like, why can't we be introduced to it in like kindergarten so we can actually like not be confused now?
I think you will understand.
Going to cancel, right? So the only unit that's left
Year.
is the year. So you take all the numbers on the top and multiply them, and you divide by every single number on the bottom.
Oh my god.
That is a big number.
Let's not do that.
Oh, you can totally do that. Molar masses are going to be your friend because they are a ratio. Right? They're already a ratio. So HCN, potassium chromate. What was the molar mass for that?
194.2 grams per.
And sodium chloride.
58.4.
Oh, that's
So, be prepared to use molar masses as ratios. There's another ratio that you have that you've been using up to this point. If you have enough, you can make a nice guacamole.
Avocado.
Avogadro's number.
Avocado.
Avogadro's number is already set up as a ratio. So you may or may not need these. You won't need all of them in one question, but you will need at least one of these in a question. Okay, so write those values down on the top of your sheet, and we'll do question 2 together. So what letter are we looking for in our question? What's the unit? Mass, so the unit is? Grams. So we want grams. Do we have a ratio up there that has grams HCN?
Yes.
We do. We have the molar mass of HCN. So we want to get rid of moles. What are you going to multiply by then? Times how many?
1.
No. How many did they give you in the question? Cool?
5.634 moles.
So the moles cancel. Do we have the unit that we were looking for? Then we stop. Then we stop. So your answer is going to be 27.03 times 5.634. Did I get the right number?
Yeah, no.
Rounding.
Okay. All right. So don't keep going and throwing numbers in, other ratios in. If you're done, if you already have the unit that you want, you just stop. Okay, so B. It says calculate the moles of this mass of potassium chromate. What is the unit that we want in our final answer? Moles. So is there a ratio up there on the board that has moles in it?
Yes.
Right, it's the molar mass. But moles is on the bottom, so you have to flip it. 1 mole has a mass of 194.20 grams. We want to get rid of grams of potassium chromate. So we must have a number or a ratio that we haven't used that's got grams in it. Ara?
Or wouldn't we just multiply by 257.345 grams of potassium chromate?
We would. Grams is going to cancel. And we're left with moles. So you're going to take 257.354 and divide by 194.2. You okay with that? So we always are using multiplication signs in ratios. What comes next depends on what's on the bottom of your ratio. Once you cancel and get the units that you want, you stop. Try the next one. 6.02 times 10 to the 23rd atoms of silver per 1 mole of silver. Do we want to use it like that, or do we want to flip it? Ryan, what do you think?
I have no idea.
What does the question ask for?
How many moles?
So we want to flip it because we want moles on top. 1 mole, 6.02 times 10 to the 23rd atoms. We want to get rid of atoms. 2.57 times 10 to the 11 atoms. Our units that are going to be left are only moles, so we stop. No more ratios. So you take 2.57 times 10 to the 11 divided by 6.02 times 10 to the 23, and you get 4.27 times 10 to the negative 13. Check your calculator. Make sure it's not lying to you. 8.24 times 10 to the 23 formula units of sodium chloride in a salt shaker.
22.
22 times 10 to the 22.
Sorry, 10 to the 22. Formula units of sodium chloride. It wants the mass. So what letter are we looking for? The unit. It's asking for mass. What's the unit? Grams. What do we know about sodium chloride? Go back to the top of your sheet.
8.45 grams of milk.
There's 58.44 grams in every 1 mole. That's great. Do we know how many moles we have? Are you given moles in this question? No. Is there a relationship between moles and formula units? Avogadro's number.
Oh, there we
It's always there.
go. It was always there.
Those are the 3 values you will need to solve D. I want to go home too. The next ratio has to contain moles because it's on the bottom. But now I'm stuck with formula units. Isaiah, do you know the answer? And you're packing up.
I was doing 196, 146. I think
Now formula units cancel. You're going to finish these questions, and there's some questions on Schoology. There's about 4 from your textbook. Okay? Try doing these using dimensional analysis. The answers are posted.